Yeah, I'm glad
But
it's
at
done
least
now.
it's done.
Yeah.
Yeah.
And
Good. What's that?
I said, hi, Britton.
Hey guys, how are you?
Good, how are you? Are
Pretty good.
you hanging out in the library?
No, it's the BYUI Center.
Oh, okay. Well, it's
Yeah.
fancy.
Yeah.
are you glad the test is over? We were just talking about that test being done. I'm glad.
Yeah, it was all right. Like there were a few things that were kind of confusing, for sure.
I don't
Brittany,
like closing a test and not having any idea how well I've done. You know?
Oh my gosh, yeah.
Yeah.
I'm
It
like,
drives
I
me
could
crazy.
get a C on this, I could get an F on this, I could get an A on this. I have no idea.
Yeah.
yeah. But you immediately got your grade, right?
Yes.
Oh, you mean like
Yeah.
when you pushed submit? Yeah.
Yeah, when I'm ready to end it, I'm like, I don't even know if I need to go back and revisit these things because I don't know what else I would put.
Yeah,
Uh-huh.
yeah.
Yeah.
That's exactly how I was. I was like, well, I could go back over this, but chances are I would just get it wrong, but a different answer.
Mhm.
So, anyway,
Yeah. I wish it would show what we missed.
exactly. That's what I was about to say. Like, that drives me insane.
It does.
Yeah.
Well, the TA I found out that's her job. Like she said, "Oh, I haven't had time. I'm supposed to
Oh.
like let you guys know." And
Oh.
she goes, "I've just been really busy." I thought that would have been helpful though
Yeah, for real.
for the last ones, you know.
Yeah,
Yeah.
sure.
Yeah, for sure.
Jenny, did you study your eyes out? I was thinking about you. I was so worried about you.
Oh, thank you. Oh gosh, you know what I did, and I mean, poor me. I was we're visiting our daughter right now, so we're in Hawaii, and
What?
Fun!
yeah, and so the whole plane ride, I read the whole textbook, like all the chapters, like page by page to every problem and stuff. But yeah, honestly, it didn't really pay off. I'll just say that.
I'm
Oh,
sorry.
It's okay. I just got to figure this out, and there's nothing more. After I didn't. I was like, there's nothing more I could do. So I need to just talk to her and say, maybe I could retake these tests. Not that I want to, but
You should
um,
ask her.
Yeah,
Sorry,
maybe
yeah.
guys,
so.
I'm eating. I'm starving.
Oh,
Um,
please do.
but I emailed her to ask about the test, and she said she can't reveal any information until everyone's taken it. And she said one student is retaking it today, and
Oh,
someone's retaking it. So maybe you could email her to retake it.
you know what? That's true.
Yeah, you never know. I mean, there's a difference between doing your best and having a difficult time and then, not trying and having a difficult time.
Yeah.
Right.
Well, you guys are so supportive. You know which one my scenario is. Like, I don't know what more I could do. I just, and I didn't even get to open up all the files. There's one file I didn't get to open.
You're
Oh,
kidding.
really?
oh, well, yeah, you should totally be able to retake it.
Yeah.
Being able to open up.
That's so frustrating.
The most frustrating thing is like some of the files not opening up and
Yeah.
Yeah. Did you guys have to do like fancy things to them? Like, or were they pretty straightforward? Because like I just couldn't get like the descriptives data. Like I just thought, am I doing this wrong? What am I not? Am I not?
I didn't have to do too many fancy things on it. I was surprised. I thought I would have to do more, but I didn't have to do as much as I was anticipating.
Yeah. Okay.
I
Yeah,
don't
there was
even
one I wasn't really sure
know.
on. But
What'd you say, Tori?
I said I don't remember anything. I erased it from my memory. So I couldn't tell you.
Anyway, but thank you. Thank you for all your help and support, and just carry on.
I know. Okay, so how'd you guys do with lesson 16?
Well, if I'm being honest, I usually have plenty of time to do stuff in the morning, and I mean I got everything done, but I still my brain isn't completely wrapped around it because Athens been fun. So I think she's
Yeah.
eating again.
Oh goodness.
Anyway,
I'm the same way. I did it, but I haven't like solidified. Like I had to do it so quickly that it hasn't solidified in my brain yet.
yeah, that's where I'm at.
Because when I see the word pea hat, I'm like, is that the pea with the little hat on it? Like I'm assuming it is, but I don't remember even reading that in the textbook. Did you guys read
I
that?
don't either. There were several things that I
I'm
didn't remember
assuming
seeing.
that it like
It's in the video, and you're exactly right. It is a P with a little hat on the top.
yeah, it's like the little thing, right?
Asterisk thing.
It's like how ridiculous, and they literally say P hat.
But what is it though? That's what I didn't understand very well. Is like what it actually represents.
What it stands for or whatever.
Yeah.
I do
It was
know.
like the probability of something.
It's the sample proportion. It's a point estimator. I have it written in my
It
notes,
is.
but I just never saw it referred to as pea hat.
It is a sample proportion. Yep.
So is the sample proportion that's like say 10 out of 100 people or whatever? Is that what that means?
I think so.
Okay.
So you could have like 5 p hats for a different pie chart, technically.
What do you mean? Say that again?
So like for example, if we had like 5 data points and we made a pie chart, would there be like a p hat for each category?
I don't know it well enough, but I would think that if you had the pie chart, like it would be of the whole, right? Because like if you had, I mean, I guess it like if you're doing the sophomore, junior, senior thing. I don't know. Now I'm confusing myself. I don't know, Britton. You would know better than I would.
I feel like it would be because like yeah, say like 10 of 100 are freshmen and then 30 of 100 are sophomore or whatever. Those are two different.
Right, but that's 100 meaning of all the students, freshman, sophomore, junior, senior.
Yeah.
Weren't you saying like individual, like just freshmen, just
I was meaning like if the entire student population was 100.
That's
Right?
what
So I would think like all the p hats together would equal 1.
Yeah.
Well, eventually. But anyway, we can figure that out later. I don't want to.
that makes sense.
Baby. Hey.
So when it said, I mean, do you guys want to just go over the part 2 then?
Yeah.
I say we go through it all.
Dang.
That would be helpful.
Okay. Hey, here's this. Here's a toy.
Okay, so for number 6, did you guys do the did you weight it, or did you just make a plain? Did you weight the cases, or did you just make a plain pie chart?
I just made it plain. I don't know, like, how do you know whether or not to weight it?
Well, I went and I looked at the data, and it in the book it said something to the effect of if it's like a summary. And I went and looked at that data, and I didn't see anything where it said multiple people were being counted in that particular set. So I just did a regular thing. But then when I looked at the answers, it had a different little annotation on the pie chart than mine did. Did yours?
Yeah.
Yeah.
That they like labeled it with the percentage, but I don't know how to figure that out. Maybe if we do the weighted thing, then it does.
Yeah. In the video, it said when using summarized data, it's necessary to weight the cases.
So was that summarized data?
It like doesn't say anything about the data.
I know it really
I
doesn't.
don't even know if it's. Let me see. What did they say? What does weighted mean again? Like,
Isn't it like the amount, like the percentage, pretty much?
okay.
Uh,
I don't know. I didn't understand it either.
Yeah, I just feel like all of it would be weighted then.
I think the weighted is like if you have multiple, like if you're saying of all the freshmen, like there's a certain, like kind of what Britton was saying, like there's like 15 freshmen. Well, instead, like that's a summary of 15. Like if you want to weight it and make sure that you're accounting for each of the 15 freshmen in that group, then that's when you weight it to let you know that there's multiple people in that category.
So then my question would be, how do you weight it? Because it brings up that option when you make a pie chart about like summaries and stuff. Do we do something with that?
yeah.
It gives you the directions of how to weight the cases. Is that what you're talking about?
Yeah, because I need to just read through it again probably, but
Yeah, it's like when I did my first pie chart, it was all equal, and I thought, wait a minute, like all the pie pieces were equal.
Oh, it was?
Yeah, and so it says like by default, SPSS assumes that you're analyzing survey data. That means that each row represents one individual. So if you have the data where it counts to be summarized, the slices of pie chart will all have. Okay, so it says. Then when I weighted it, then they were different proportions, Let me see, open the data file. They should, okay. It says,
Jenny, did you have the little, after you weighted it, did you have those little markings, like the percentages on your pie chart?
no.
You didn't?
It was on the side, in the key. Okay.
So the percentages were in the key?
Yeah, on the side. But like that picture that we're seeing right now, it didn't have those little boxes on each piece of pie.
Okay.
Yeah.
But mine had the boxes off to the right, like saying junior, freshman, senior, but it didn't have any numbers associated with it.
Oh, okay. I think mine did.
Yeah, that's how mine was, but
It was saying before creating a plot with summarized data, you need to weight the cases.
Well, why don't we go ahead and just open the file and weight the cases and see if it looks like what the answer key looks like? Because I haven't done that. Are you guys okay with that?
yeah, I'll do that. Try it.
Okay, so you go to the class survey and then you go to data or data. Do you guys all say data? Am I not supposed to say data? Am I saying that the wrong way?
I say it that way too.
I say both.
Yeah, you can say whatever you want.
Okay. Thanks.
Okay, well, I have a question then. So when I open up weight cases,
Mm-hmm.
you're supposed to we would weight it by the classes, right?
I think by the rank.
Rank, yeah. Class rank. Well, that's not an option.
Yeah, that's not an option. So
I don't think we have to.
yeah, I don't know actually what we would weight. Because any of those, because I just opened it, and none of those would really work.
Yeah. I mean, they're wanting us to make a pie chart for class rank, and none of those are the class rank, so.
Well, and we did that. That's what the pie chart was. I mean, my pie chart looks just like theirs does, except with the numbers.
Yeah.
So, okay. Well, hopefully we do it right if we're quizzed on it.
Yeah.
We'll figure it out.
And then the bar graph, did you do the same thing, right?
Yeah.
Yeah. I don't know how they're computing like the percentages. Like
I don't either.
I don't get
I
it.
wonder. I'm gonna try something really quick.
So one thing they did say, under that little like how to make the pie chart, and then it tells us how to weight cases. it says if you have data where counts have been summarized, hey, I lost my place. Yeah, slices in the pie chart you just created will all have equal areas. Oh my goodness, baby. Basically, like what let me see, I feel like I might get it if I try to explain it. So like right now, like the data that we were given, was just like clusters of students or whatever, and so never mind. I don't know what I'm trying to say. I'm trying to figure out how to explain
It's
this
good to talk it out.
read it. I can't figure out how to. Yeah, never mind. Forget I started talking.
Fine.
Oh, I might have got it, kind of.
Okay, try to explain it.
Oh, I just figured out how to do the percentages is all.
Oh, well, how did you?
So all you do is you're gonna double click on the chart, and
Oh,
it brings up the chart editor.
Yes, I did that. Yes.
And then you go to options, and where is it? No, sorry, elements. And then let me do it one more time.
show data labels.
I think so. No, that's
Elements.
not it. Sorry, I have it, but
Did I write that double click?
Yeah, I did. Yeah, when the pie charts were all equal, then I double clicked on the bar chart, any portion of it. It says it's going to turn yellow, but it didn't. But
It says to go to edit, and my note says edit and then properties.
yeah, that works too.
And then what do you do?
And you click the categories tab.
Yeah, and then there should be two on the bottom, and you have to arrow them up to the
Sort
top.
by label.
Yeah, like I think it says rank, and then another one is percentage or something like that.
Mine won't open. Like I can go to edit, and then I can go to properties, but once I try and click on it, it won't open anything up.
Yeah, let me try one more time.
Edit. Properties.
Yeah, if you can go into that and go to variables on the rank, well, let's see. It's different now that I got them on there.
Is this on the pie chart?
Yeah. We could do it for the bar graph too, though. Let me do.
Okay, I got it. So
Open the bar graph too, and I'll do it on there.
okay,
So I'm not seeing where, like, you guys are talking about how to add the like percentage to it or the value.
Yeah. So I'm gonna try to do it again, but with the bar one, so I can see what it would look like for you guys.
Oh, go ahead, Corey.
Well, I was just gonna say the notes that they talked about, or when they talked about like going to properties and then, oh, now it's not even showing up. Well, oh. Well, now it looks different than it did 10 seconds ago, so never mind.
Oh, okay. So here's what I did. So you're gonna double click on your chart.
On the bar graph?
Yeah, we can do it on this one first. So double click on it, and then click on elements, and go down to show data labels. It's the second one down. It should pop up for your properties screen.
And get those little labels.
And then it has displayed count and below that not displayed rank and percent.
Right.
So if we just move rank and percent up to the displayed tab, then they should show up on there.
Oh yeah, there we go.
Yeah, that works.
But anyway,
So it was double click. I have to write it down.
Whoa. Hey, where'd your pacifier go, huh?
Okay, so watch us not even need that, and we just spend all that time doing it.
yeah, for real.
Good practice.
Yeah. Okay. At least we have that. So thank you for figuring that out. So I think that's all we have to do for 6 and 7. Should we move on to 8?
Sure.
Why do you keep sitting in?
So it says use at least 5 descriptors to describe the data above. And for me, like that was just a weird question. I don't even know. Like I went and I looked at the answer on our assignment, but I was like, what specifically are they wanting?
I didn't know either.
Well, I feel like it'd be easier now that we know how to label it, because we could say like,
True.
I don't know, 'cause now you can actually see the numbers.
So we could just describe, we could say the such and such class is this, that, and the other.
Yeah, like
Mhm.
there are, I don't know, 10 times the amount of seniors or sophomores as there are freshmen, or I don't know. You can.
Yeah, that could work.
I mean, 5 descriptors seems like a lot. I mean, I guess you could say there are, 8 freshmen, 59 juniors, 75 sophomores, and 39 seniors. That's 4 descriptors right there.
There you go.
Yeah.
So maybe we did need to know that in order to be able to describe the data.
Maybe so.
Okay.
Yeah.
Okay, yeah, that makes more
Otherwise, we
sense.
just have a picture and nothing else really to go off of.
Right. Okay. So that probably works, right? Are you guys good with that for number 8?
Yeah.
Yeah.
Okay. So number 9. So I thought A, that one worked. Did you guys have a hard time with that one? Did we go through it?
I have figured it out.
Okay. Well,
How do we know what to round to? Like, what did you round to for the standard deviation?
it just came up. Like, here, I'll put maybe it's still in my. Oh. Oh, that's interesting because I just was looking at the answers to try and find out how to get the right answer. So once I got it, then I just wrote down what they did. But technically, it should probably be 0.009, and they have 0.0093.
Yeah.
Yeah, yeah.
I mean, it's the right answer regardless. So.
Yeah.
But as far as that formula, that's what I'm going for. It was the P, and we know the P is the 0.07 because it tells us that in the problem.
Yeah.
And then it's 750 thousand meters, so that's the N. So then you just compute that, and that's how you get the standard deviation.
That's not great.
That's the 0.07 times 1 minus 0.07, all divided by 750, and then you take the square root of that.
Sorry, guys. Just so.
Yeah, that's what I got. So.
Okay.
Does anyone have questions on that?
Nope.
No.
Yeah, I just followed their example.
You're
Okay.
great.
So B, I didn't really understand what, like the P, I don't know.
I didn't either.
I didn't get what it was trying to say.
Even after looking at the answer, like I see what the answer says, but I still don't understand why that's the answer.
Yeah.
Yeah. Like I get that it's the P hat, but I don't understand the P parentheses P hat is greater than, unless it's
Is the
almost
big
like the null hypothesis, kind of.
is the big P supposed to stand for probability?
Probably. And then I guess we are looking for the probability that more than 60 users use only cell phones. So I guess that makes sense.
Yeah.
But I just don't so the p hat we said was the sample. What did we say it was?
Sample proportion.
Sample proportion. So I don't know what this like. How do we find what the sample proportion is?
So,
Is it
for
60?
example, well, in this case, yeah, since they want to know the probability that more than 60 of the 750 only use cell phones. So they should give us a proportion, I believe, if we're ever gonna like have a p hat or find one.
So meaning like the proportion would be the p, not the p hat, right?
No.
I guess like I guess maybe it's just saying state the problem in terms of the variable. They just want to know that we're trying to figure out what the p hat is, like that it's because it's wanting to know if it's more than 60 users. So it just wants us to show. I guess just write it out.
It's pretty much our hypothesis.
Yeah, like we were doing
Okay.
before.
Yeah,
Okay.
it's a little different, but kind of similar.
Yeah, the steps are.
Okay.
Yeah. It's weird.
Yeah. I mean, it's actually probably pretty simple. It's just writing out what it's asking for, but it's just something I haven't seen. So.
Yeah,
Yeah.
me too.
Okay.
Okay, so then drawing a picture. It's pretty easy, right?
Yeah.
Right.
So how
right.
do we? Are we just assuming whenever we do these problems that it's always to the right? Like that's
Well,
the.
it says more.
Oh. Okay.
So technically, we could get a z-score and then go to the probability and okay, yeah, that makes sense.
And in fact, they want us to do that.
Yeah.
On D, but I didn't.
Yeah, and I
didn't
did that.
remember
That's the
how to-
part I actually understood. So
As D.
yeah,
Oh, good, because I didn't. I have the formula, but I didn't know what the p hat was in order to compute it.
so
Is
it's
that
just the
60?
0.08.
The p hat is the 0.08?
Yeah, because it's a percentage. Like it took me a while to figure it out too, but since we know that p is 0.07, then we can assume that the p hat is going to be a decimal as well, since we're never going to have a p hat greater than 1, I believe, because that would be impossible, I think. So it should always be a decimal.
Okay. So I'm going to try and do it out really quick. Is that okay?
Of course.
For D.
Yeah.
Okay. And of course, for the next two, I was a little off because I had used the the answer for the standard deviation instead of like doing that whole formula for the denominator. I just put in the answer, but since it was rounded,
Oh, yeah.
I was off by 0.002.
Yeah, at least you knew you were in the right area.
And it seems like the lessons after the tests, even if they aren't that hard, they're hard.
Yeah.
Because you're just kind of like burned out.
Okay, did you guys get then 1.07 for the z-score?
Yeah.
You.
Good
Okay.
job.
And then you just plugged it into the normal probability tablet, right?
Yeah.
0.14.
Okay. So then so the area, did you get 0.142?
Yeah.
Mm-hmm.
So, but then I don't know how to interpret that. I don't know what that means.
So the probability or the area under the curve, the 0.142, that's the chance of getting. I wrote it a little differently than what the answer said, but it's the same thing. Like there's a 14% chance that more than 8% of the people or phone users use cell phones. Does that make sense?
Yep. Yep.
Or like the probability of, there's a 14.2 probability that more than 8% of the population, or more than 60 people or phone users use cell phones exclusively.
Yeah.
Perfect. Okay,
Yeah.
I hadn't thought about it.
Yeah, you just use like, there's this chance that. That's how I'm going to describe them or interpret it.
Are we
Yeah,
allowed to say chance on this one, or do we have to say probability?
I don't know. I think it.
Probably probability.
They do say chance in the answer key.
They do.
Oh, do they?
Yeah.
Oh, yeah, that's true.
I haven't looked at it, so.
But I'm sure both would be fine. Like,
Yeah.
I think
Where
so.
it's multiple choice, too, we'll be able to figure it out.
yeah, and they haven't had us like, other than numbers, we haven't had to fill in the blank with our own, typing. So anyway. Okay, well, are we ready to
Yeah,
attempt?
let's see what it looks like.
Let's do it.
Oh, 17 questions. Number 3.
Okay, does everyone have it open?
Yeah.
Yes.
Yep.
Okay. I'll just read the first one here. In a pie chart, why are the slices or sectors different sizes? Pie charts are more visually appealing when the slices are different sizes. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by that category. The size of each slice is random. The size of each slice is determined by the number of categories. So,
B.
Number 2,
Yep.
okay, how are bar charts and how do you pronounce that? Pareto? Pareto?
Pareto.
He said it in the video. Let's see. Pareto? Oh, whatever.
It doesn't matter. Okay, how are they related? They are identical. Pareto charts are constructed from tossing a coin several times. Or the only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest, going from left to right.
The last one.
That last one.
Okay, so for 3 you did the second one, and for 4 you did the third one, right?
Yeah.
Okay, we conclude that p hat is normally distributed if NP is greater than or equal to 10 and n parentheses 1 minus p is greater than or equal to 10. Is p the true proportion or the sample proportion? That's the sample. Oh,
Is
true.
it? I was
I think
thinking
it's a true proportion. But
it's true, but
I don't even. What are they? I don't even.
P. Let's see.
yeah, it says p hat is a point estimator for the true proportion p.
Okay. I don't even. Oh. Yeah. You're right. I even have that written down right in front of my face. Okay.
That's okay.
Way to keep us on our toes. That's good.
Okay, so what is n? That's the sample size.
Yes.
Yeah.
Okay. So if p equals 1 divided by 4, what is the smallest n that satisfies the requirement?
This would be 40.
Yes. Oh, yeah. Yeah, because we're looking at that formula.
oh, because it has to be greater than or equal to 10.
Yeah.
Okay, my brain turned off. So can you explain that to me?
Yeah, thank you.
Sorry, what? Say that one more time.
Can you just explain that to me? Because my brain isn't working.
So that formula up at the top
Mm-hmm.
includes that p hat is normally distributed if np is greater than or whatever. What is that? Well, what are you wanting me to explain? Like
How
why
you
that
get
is
40?
or why the answer is 40?
Why the answer is 40? So because so 1/4 is 0.25, and then you have to multiply that by something, and it still has to be greater than or equal to 10. Is that what you're saying?
Yeah.
Yeah. So if you plugged
Oh.
in, like if you put just 1 over 4 next to 40, 4 goes into 40 or whatever. If you multiply that, the answer would be 10 or whatever. Does that make sense? So like p 1/4 times what number equals 10, and that's 40.
Yeah. You can even put it in the formula, like np equals 10, and then you can solve for p. So just divide 10 by 0.25 on both sides, and then you get your p equals 40.
Okay. So
And
just
then you can
simple
check it with the other formula too to make sure that it is greater than 10.
Okay, Jenny, do you understand that, or do you want to explain it again?
No, I wrote that down like well, no. I wrote down what you guys said, and so
But do you understand it? We can explain it again.
okay, go ahead one more time.
Okay.
Okay. Who wants to explain it?
You can.
Okay. So if we look at the formula in number 5,
Yes.
we need n times p to equal at least 10. And so we can set up a formula for it since we know what our p is, which is 1/4 or 0.25. So we could write the formula out as n times 0.25 equals 10. And then if we want to solve for the n, then we need to divide both sides of the equation by 0.25 so that n is by itself.
Uh-huh.
So if we divide 10 by 0.25, that'll give us n equals 40. I don't know if that makes sense or not.
Yeah, it does. I'm going to do it in the
And so do you get on the other side, when you plug it into the parentheses equation, that it comes out to 30?
Yeah.
Okay. I remember them saying you have to make sure both sides fit, otherwise it doesn't work or something.
Yeah.
Okay. Okay. Thank you, Britton.
Uh-huh.
All right. Are you ready to move on?
Mm-hmm.
Okay. Use the following information to answer questions 8 and 9. suppose n equals 24 and p equals 0.4. So number 8, what is the mean of p hat? Isn't it 0.4? I have written, well,
No, it's the p hat equals x divided by n. But I don't know what. So
Yeah,
x
we
is
don't know what our x is though.
the number of individuals in the sample with the curve.
but it's asking for the mean. And I wrote down
Oh, true.
that p hat, well, hold on. Let me find it just so I'm not. The mean of p hat is p, but, which doesn't make sense. That's what I wrote down. So let me see.
Huh.
I can find it.
Oh, it says the mean of p hat equals p.
Okay.
So,
Yeah.
yeah, it's 0.4.
That's actually not for babies. Sorry.
So you're just writing 0.4, right?
Yeah.
Yeah. Sorry, guys.
That's okay.
Fine.
Okay, number 9.
What's the standard deviation of p hat?
Well, if p and p hat are the same, I don't get how there's going to be a difference.
Well, the standard deviation for p hat is
Oh, it's a little different, huh?
yeah, it's p multiplied by 1 minus p divided by n, and it's the square root of that.
Yeah, you're right. So
I think it was saying the mean is the same as before.
yeah.
Okay, are you guys doing that math?
Yeah.
Okay.
Did you get 0.1?
Yep. I
I'm not
did.
quite there yet. Hold on. Oh, yeah. Yep.
These small numbers just throw you off. It's like, oh, is that the answer?
No.
Okay. Use the following information to answer questions 10 through 13. Brittany's batting average is 0.3. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. Sample is 100, P is 0.3. What is P hat? So you said it would be, would X be 35?
I'm assuming so because it says that X is the number, well, on this I wrote the number of individuals in the sample with the characteristic I'm focusing on.
Okay.
So that the number of hits would be the number that you're focusing on.
So it's X divided by N, right?
Mm-hmm. So
Yeah.
0.35. Okay, so what is the standard deviation? So I got 0.046.
that's what I got.
Boo! Hey. Boo.
What did you guys say you got? 0.046?
Yeah.
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 Boo.
And
Did
you
you
just
get that, Jenny?
yeah, and you just use that we just use that formula,
Yeah.
the p minus the 1, well,
P
1
multiplied.
minus p,
Yeah,
and then by the sample size, and then you square root it.
correct.
Yep.
So it's the standard deviation of p hat. That's the thingy.
The formula. Okay.
Mm-hmm.
Yeah, I got that.
Okay, so then for the next one, what is the z-score? That's going to be the p-hat minus p, right? On the, like the numerator, and then divided by the standard deviation.
Right.
Okay.
So 1.09.
Yeah, well, we need to round it, right? Round to 3.
Oh, did it take a 3? Yeah, sorry.
Yeah.
Haha.
So
Thanks for reading.
0.08.
Let's see. What did you guys say you got?
1.087. Is that what you got, Tori?
Yeah. Okay, so what is the probability that Brittany gets at least 35 hits in her next 100 bets? We put it into the applet, right?
Mm-hmm.
Yep.
1%.
So when it says at least, do you just shade in the middle portion? Like, what do we shade in?
Should be anything above the z-score. And isn't it a negative z-score because it's lower than the p?
Oh. Oh my gosh.
Like it. Let's see. Because yeah, our z-score should be negative 1.08.
Oh, yeah, it should. I must have typed.
Turner, is it supposed to be P minus P bar or P hat?
No, actually, I don't think it is. It's just 0.35 minus 0.3, which
Well,
is
it's
0.05.
it's the p hat minus p, which would give us a negative 0.05.
It would give a negative?
Yeah, because the p hat is smaller than p. Because the p is 0.4, right?
The
The P is
P is 0.3.
Oh, yeah.
0.35.
You're so right.
So I don't think it should be negative. I keep
Yeah,
reading.
you're right. I used the value from 9.
Oh,
So
gotcha.
it is, yeah, 1.087.
So you just shade the middle?
But that's what I'm not
So
exactly.
it would just be the upper value then because it's larger than p.
Because it's at least or bigger.
Yeah.
Okay, so it's 0.138 or 0.139 rather.
Yeah.
Do
Well,
we
I thought
round?
at first, but then I wasn't sure.
Yep. So
So
our
we don't
z-score was
round it or anything?
to 3 decimal places, yeah.
That is rounded.
0.
Yeah. So number 12, we had 1.087 and 13, 0.139.
Yeah.
Okay.
Did you get those, Jenny?
Oh yeah, I got those.
Okay, great.
So 14, if the true proportion of people who support a political candidate is 0.52, and if n equals 2,000 people are surveyed, we want to determine the probability that the result of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of p hat?
So
It would be 0.5. Well, no, point. Wait.
we have to figure out.
So P is 0.52. Baby, we're almost done.
I feel her pain.
Yeah.
Yeah. So
The
go ahead, Britton.
0.011.
Yeah.
That's what I have.
Okay.
And use that formula.
The standard deviation of p hat.
Yeah, okay, good. The square root thing again. What's the score?
Okay, so yeah, so then for P hat, what is P hat?
So I was thinking, would you do like 0.50 divided by 2,000?
Okay, wait.
For which one? Number 15?
Number 15
To
to
find
We're
find
the
looking
what
for
p
the
hat is.
z-score. And we know our p-hat from what it explains in 14,
We don't.
because it's the probability that the results of the survey will suggest a candidate is losing the election, getting less than 50% of votes. So our p-hat would be 0.5.
Okay.
Does that
Oh,
make
really?
sense?
That makes sense.
Wow.
Unless, well, it says less than 50%, so I don't know if we'd have to use 0.49.
Oh. Oh goodness.
I mean, we are going to do to the left of it, so I think we should be fine using 0.5.
Yeah, I would say use 0.5.
Okay.
That's my
So,
guess.
and we know that that's p hat because why?
Because it tells us that the value we're checking for is, well, the probability of if they're losing the election, like getting less than 50% of votes. And our p-hat is like what we're comparing to p.
Okay.
I don't know
Well,
if that
and
makes
actually
any
that makes
sense.
sense if you
It's
look at
hard
what
to explain, but
If you read the question, yeah.
it makes sense because p is 0.52, so it makes sense that p hat is 0.50. Because they're usually pretty similar, haven't they been?
yeah.
Yeah.
Okay, I'm just going to have to remember that. So that's what p hat is then. Because I don't think in our homework though, is that how we found out what p hat was?
P hat was, well, to like compute it or whatever, it was x divided by n, which don't really have x. Right? Isn't that?
Well, that's why I was just wondering if it would be like x would be the 0.50 divided by n. That was what I would have originally gone to. But if it just tells us, then that's great. I just didn't know that. I didn't read it that way, so I just need to remember for the future.
Okay. Oh, baby. Are you studying?
But if you look at in our homework, guys, if you look at not in the homework, in the preparation, if you go to number 9 and then part B, it says that, and I'm probably wrong. I just have to talk it out. Sorry, just bear with me. That might drive you crazy.
No, you're great.
It says that it's 60 over 750. And it says, what is the probability that, well, maybe it's because it, yeah, maybe you're, okay, I think you're right. Sorry, I'm just having to hear it and see it. Because then it's using that or the 8%. Okay, all right, we'll go.
Okay.
Sorry, guys.
Don't be sorry.
Okay.
So now the Z, are you guys getting a negative Z-score?
Yeah.
Okay. So I got negative 1.818.
Yeah.
I got
Yeah.
negative 1.79.
I got the same thing as Tori.
Okay, I must have.
What did you do differently? So did
Yeah.
you use like when you put in the standard deviation, did you put what we rounded
No.
to? Okay. That's
Oh,
what
I put what we rounded to, but maybe
that's what I do too. Well, it like sometimes it's wrong, but like why would they
But I did that because we just computed it right above, so it makes sense to just use that.
yeah.
But
I was off by a little bit on the preparation assignment because I did that.
oh, well maybe, but it tells us not to round until the very end, so maybe we should go
Yeah.
with Britain.
So how did Britain? Did you just like do like the top portion and then put parentheses and did the bottom stuff?
Yeah, so it's kind of confusing. So I did negative 0.02 divided by parenthesis square root parenthesis 0.52 times 0.48 close parenthesis divided by 2,000
Yeah.
and then close two parentheses.
That's intense.
So dumb.
Wow.
Yeah, I'm gonna read do it really quick.
So basically round at the end. So does
Yeah,
that
always at the end.
Okay, well I'm just gonna trust you guys. I'm trying to
We'll
put it
see
in
if,
my phone.
let's see if one other person gets it. And then,
Hey. She like gets mad every time I start talking. Like I'm not allowed to make any noise right now. Hey. Oh my. Oops.
Okay, what did you get, Britain?
negative 1.790.
That's what I got.
Okay.
You are being a silly baby. Okay, I'm sorry. Hold on. Where's your
Okay, so number 16 is what probability do you compute using the normal probability applet?
Yeah.
it'd be the second one? Because last time.
Yeah, that's what I was thinking.
So what's the
I don't know why
capital
there's
Z?
two Z's. Yeah.
Yeah, what's the
but,
capital Z versus the lowercase z?
I
I have no idea.
don't know.
I haven't seen it.
It's
I've
not
never
even
seen
in
it.
the book.
I wonder if they put the wrong variable in there.
Oh, that's really great.
I'm sorry, what did you guys get for, you got negative 1.879? Or,
Negative 1.790.
oh, okay.
Yeah. So what's the probability? Big Z is
I mean, the natural inclination is But which one do you look at for less than? I guess that's hard.
Well, yeah, because they're both technically less than. I mean, I would almost say it's the first one
No, you have to keep
if we're assuming that, like, the big Z is referring to P, and the small z is like the P hat, but
Gosh, it's like, how do we know that?
we don't.
That's amazing. They're not talking Z-score. Z for the Z-score.
They should be.
Z.
That is really confusing. I don't know why they have these.
What probability do you compute using the normal? You compute something that's less than.
Isn't the second one less than? Like, what are you saying that both could be less than?
Oh, if we don't know which Z is which? Maybe?
Yeah, exactly. Because if it's the if we're looking like if our value that we just got is the little z, then technically the first one would be right. But if it's referring to the big Z, then the second one would be right.
Yeah.
Does that make sense?
Yeah, it does. It's just we don't know what Z is.
Yeah, I mean, my natural instincts go with the second one. But
That would be what, if I were on my own and not know, I would have picked the second one because to me, I just saw the big Z and it was less than, and that's what I would do. But it could be either one.
yeah.
I mean, there was nowhere in the book that it talked about this.
Yeah,
No.
I'm gonna go
Yeah.
through it again, but I don't remember anything about it.
No, I have the book right in front of me. There's nothing.
Well,
I
this
mean,
is
little
like,
z is used like to denote the z-score in the formula
yeah, that's
that we
true.
just did, but that could be, not mean anything.
Yeah.
Little Z is typically has been the Z score up till now. Like I haven't seen a big Z.
Here, one sec. I'm gonna try.
Of course, Afton is quiet now when everyone else is quiet.
Yeah, that's funny, isn't it?
Funny how that works. Silly goose.
Britton, what are you looking up? I feel like I'm kind of useless right now.
I was just looking it up online to see if anybody
Oh, that's a good
says
idea.
anything, just because if they're not gonna tell us what it is, then
Guys, I'll Google it.
Good idea. Oh, did we decide also, by the way, about that week, Tori?
Oh, yeah.
Oh, yeah, so it sounds like if everyone's okay with meeting at 7:30 Monday morning, then we can do that. But like, really, I like we can just wait, and if it comes to be like that weekend and people aren't able to finish stuff on time, then you guys can meet on Tuesday. Like I don't want to like put anyone out or make things inconvenient.
You
So,
said it's the test review though.
uh-huh.
So we have an early test again. Our next test.
Well, I'm not sure that week we only have one lesson. So it's like our spring break. So but that lesson is just the review. Like it's
And then we take our test.
and then yeah, but I'm not sure when the test is due. I just know that our group meeting stuff is due by midnight on Tuesday.
Okay.
So hopefully we have more than that time to actually take the test. But
And tell me that date again. I don't have the email open.
so March, it would be, if we moved it to Monday, it would be March 14th.
Yeah,
Yeah, I think that's fine with me.
totally doable.
Okay.
I'd have to do it, like I said, at like 7:30, but if that works
Well,
for you
yeah, and
guys.
that's like, there's no way I'm gonna like have you miss half the meeting just because we're trying to make it so that I don't miss it. Like,
No,
so
it's
yeah,
okay.
we'll do 7:30, and if we feel like we need to do earlier, we can do earlier too.
Okay. Yeah, we'll see how the material is going up to the test and how much
Yeah,
time we'll need.
I think that's a good idea. We'll
Okay.
we'll just kind of play it by ear.
Okay.
So, I couldn't find much for this. The only thing I can find is little z is a particular value, and big Z is a variable that represents all the possible values less than little z.
Well, then maybe that's what it is. Because P
So
or
that would
little z,
mean,
if little z is like, I don't know, the z score for 0.52 or whatever.
so that would make sense for the second one, I think, if the big Z is representing all the values lower than Z. Like every value lower than our Z score.
Which makes sense because we're trying to see if our candidate would lose.
Lose,
not
yeah.
win. So I think we're safe putting
I
it.
think number 2 is right.
Yeah.
Yeah.
Go with
Based
our.
on that.
Yeah. Okay, so 17, what is the probability the survey results will show the candidate is losing even though the true Z is 0.52? So is that, do we highlight what's left of the
Yeah.
Z score?
That's what I did.
Yep.
So then 0.139?
I've got 0.0367.
Oh, you know what? I never changed the Z
Oh,
score.
okay.
I have 0.037. That's
Yeah.
but oh, you said 6. Oh, you had
Yeah,
it.
I just didn't
Gotcha.
round it as all.
Yeah. Round to 3.
All right.
So
Well-
0.037?
Yep.
Mm-hmm.
All right. I'm gonna submit it.
Me too.
You guys are incredible. Seriously.
Oh, we got it.
I don't think you've ever missed one.
I think we missed one.
Yeah, at least a couple, I think.
Um,
Well, I'm just glad we do well as a group. By myself, I don't get 100 all the time.
Yeah, me either.
oh, I don't either.
But that's a benefit of talking it through and stuff.
Yeah. for
Yeah,
sure.
it's too bad we can't take the tests together.
Right?
Amen.
I did just like yesterday for the first time. I decided I'm like I love our group. I think we're so great. I wonder how good we actually are. And so I went to one of our quizzes and I did the class statistics. So and I'd never checked. Like not all groups get 100 every single time.
Yeah.
Yeah,
So-
that's true.
We are actually a really good group together because we're doing well on those quizzes.
Yeah. I'm
Yeah.
the best cheerleader ever.
No.
No.
Yeah.
Jenny, you are so great because you help it reinforce it for all of us.
Yeah.
Oh, bless you.
We have to teach it or like try to explain it. It helps it stick.
Yeah.
They have
Thank
to
you.
explain it for me and then for you, and then they're like golden.
Okay, you're welcome.
So yes.
Okay, so I'm gonna stop the broadcast.